Welcome! Today, we're exploring control structures in Python, which are fundamental for directing your program's behavior. These structures are crucial for guiding the flow of your program, allowing it to make decisions and repeat actions. Let's begin with conditional statements, which are core concepts for implementing decision-making logic in your code. Conditional statements allow your program to execute different code branches based on whether certain conditions are met. The if statement is fundamental. It executes a specific block of code only if its associated condition evaluates to true. This means the if block runs exclusively when the evaluated condition is true. Otherwise, it is bypassed entirely. Next, the elif statement allows you to check additional conditions, but only if all preceding if or elif conditions were false. It provides an alternative path, checking a new condition if earlier ones didn't hold true, ensuring sequential evaluation. Finally, the else statement acts as a default. Its block executes if all preceding if and elif conditions turn out to be false. The else block ensures a fallback action, providing a path when no other specific conditions are met in your program. Nested conditionals involve placing if or elif statements inside other if or else blocks, enabling complex decision logic. This allows for sophisticated, multi-layered decision-making, where one condition's outcome influences further checks. Boolean expressions are the heart of conditionals. These are conditions that always evaluate to either true or false. They often use logical operators like and or, and not to combine or modify conditions, yielding a simple true or false result. Now, let's trace exactly how conditional blocks execute, understanding the precise flow of decision-making in your programs. This sequential process ensures that your program makes logical choices based on the conditions you define. First, the program evaluates the initial if condition to determine if it is true or false. If the if condition is true, the code within the if block is executed, and the rest of the conditional structure is skipped. Otherwise, if the if condition was false, the program proceeds to evaluate the next elif condition. If that elif condition is true, its corresponding block executes, and any subsequent else is ignored. If all preceding if and elif conditions were false, then the else block is executed as the final fallback. Let's look at some code examples to solidify our understanding of these control structures in action. These snippets demonstrate the working logic, providing practical context for the concepts we've discussed. Here, we see a simple if statement, a fundamental construct for conditional execution in programming. The if statement checks a condition. If it's true, the indented code block executes, otherwise, it is simply skipped. This code sets an age, and then uses an if statement to check if the age is 18 or greater, printing a message if true. Now, let's examine the if-elif else structure, which allows for multiple conditions and a default action. The elif checks another condition if the previous one was false, and else runs if no prior conditions are true. This example assigns a score, then uses if-elif else to determine and print the corresponding letter grade. Let's dive into exploring iteration with loops, a fundamental concept for repeating actions in programming. Our goal here is to understand how we can efficiently repeat actions without writing the same code multiple times. First, we have the for loop, a powerful tool for iterating through collections of items. It iterates over a sequence of items, executing a specific block of code for each individual item. Next, we'll explore the while loop, which operates based on a continuous condition. This loop repeatedly executes a block of code as long as a specified condition remains true. Sequence iteration is typically used when you know exactly how many times you need to repeat. It's ideal when the number of iterations is known beforehand or defined by the size of a collection. Condition-based repetition is another approach, depending on a dynamic state. This is perfect when the loop's continuation depends on a condition that might change during execution. Now, let's move on to the code block explanation to see these concepts in action with practical examples. We will explain the working logic of loops, supplemented by clear code snippets to illustrate their functionality. Here, we have an example of a for loop iterating over the elements within a list. A for loop systematically goes through each item in a sequence, like a list, executing the code block for every element. This code defines a list of fruits, and then uses a for loop to print each fruit's name individually. Next, let's look at a while loop, which uses a counter to control its execution. A while loop runs as long as its condition remains true, so remember to update the condition variable to prevent infinite loops. This while loop prints the count variable, incrementing it in each iteration until it reaches 3. Today, we'll explore how to alter the flow of loops using special statements in our programs. Every time a loop begins an iteration, it starts by checking its conditions or picking the next item. During normal code execution, the statements inside the loop are processed sequentially as expected. The break statement allows us to immediately exit the current loop, regardless of its condition. With the continue statement, we can skip the rest of the current iteration and move to the next one. The pass statement is a null operation. It does nothing and acts as a placeholder when syntax requires a statement. Loop termination signifies the point where the loop finishes its execution, either naturally or by a break. Let's continue with our code block explanation. To understand more advanced looping techniques, we'll explain the underlying logic of these techniques with supporting code snippets for better clarity. Here, we introduce basic list comprehension, a very Pythonic way to create lists efficiently. List comprehension provides a concise syntax for creating lists by applying an expression to each item in an iterable. This code uses list comprehension to create a new list called squares, containing the square of numbers from 0 to 4. Now, let's enhance our list comprehension by adding a conditional filter. You can add a condition to filter elements, ensuring only items satisfying that condition are included in the new list. This example demonstrates creating a list of even numbers from 0 to 9 using a conditional list comprehension. Let's now summarize what we've learned about control structures and reinforce the key concepts discussed in this lesson. Here are the key takeaways that will help you understand and manage the flow of your programs effectively. Remember, conditional statements like if, elif, and else are fundamental for enabling your programs to make decisions based on specific conditions. Loops, including for and while loops, are essential tools that enable you to repeat sections of code efficiently, saving time and effort. We also learned about break, continue, and pass statements, which are crucial for altering the normal flow of execution within your loops. By nesting control structures, you can design more complex and nuanced program logic, handling multiple conditions and repetitions effectively. List comprehensions offer a very powerful and concise syntax for creating lists based on existing iterables, making your code more elegant. Ultimately, mastering control structures is crucial for writing robust, efficient, and well-organized Python code that performs its tasks reliably.